Welcome back to the Deep Dive, where we cut through the noise, take that stack of the latest research, and give you the distilled knowledge you need to stay ahead. So if you're engaging with large language models today, and I know you are, whether it's for enterprise development or just, intense curiosity, you know the prompting game is usually complex. We've all been sort of conditioned to believe that if you want stellar performance, you need these intricate strategies, things like chain of thought or highly optimized few-shot examples. It's always about adding more cognitive overhead. But today we're looking at some fascinating research that suggests the single most impactful tweak you can make, especially for non-reasoning tasks, is so simple it almost feels like a cheat code.
It really does.
What if the path to better results isn't about complexity at all, but about just simple repetition?
That is the absolute core of the research we're looking at. The technique is called prompt repetition, and it's exactly what it sounds like. Instead of crafting some perfect nuanced prompt, you just take the user's input, the query, and you feed it to the model twice. So it becomes a query.
You literally just copy and paste it.
You just copy-paste it. And here's the kicker, the immediate result. When you do this on tasks where that step-by-step reasoning is turned off, the accuracy improves significantly and reliably across every major model they tested.
Wow.
We're talking about a phenomenal success rate. The researchers logged 47 wins out of 70 different tests, and, maybe more importantly, 0 losses.
0 loss.
Not a single one. That kind of consistency for a technique that requires basically 0 engineering effort is, well, it's pretty much unheard of.
Okay, a 47-0 record is.
Because I'm saying.
That's incredibly compelling. Before we jump into the why this works, let's really appreciate the scope. They didn't just test one model on one little benchmark, did they?
No, not at all. This was extensive. They're really aiming for broad coverage of the modern LLM landscape.
So who was in the lineup?
7 popular models. You've got Gemini 2.0 Flash and Light, both GPT-4o Mini and the full 4o, Claude 3 Haiku and Sonnet, and DeepSeek V3.
So pretty much everyone, if you're building with LLMs today, you're using one of those.
You're almost certainly using one of those 7, yeah.
And what about the testing terrain? Because, an accuracy game on one type of problem isn't the same as on another.
Exactly. So they used a really robust set of established benchmarks, things designed to test knowledge retrieval and comprehension. We're talking ARC, OpenBookQA, GSM-8K.
Okay, so the standard stuff?
The standards, plus MMLU Pro and the general mass data set. And just as a quick refresher, MMLU Pro covers this massive range of multilingual knowledge, and OpenBookQA is all about factual question answering. These are not simple lookup tasks. They're designed to really stress an LLM's ability to understand and retrieve.
So the big picture finding on these respected tests is that just repeating the prompt boosted accuracy across the board as long as the model wasn't allowed to, think step by step.
That's the headline. It's a huge finding for anyone running high-volume retrieval tasks. But the research also dug into a really important subtlety, something we've all run into, the impact of input order.
Oh, I know this pain. You spend an hour just fiddling, right? Putting the context before the question or the options after. It feels like a superstition, but it genuinely changes the output.
It's a known fragility, and they tackled it head-on. They looked at how performance changed if the prompt was options first versus question first, and what they found was critical.
Well, was it?
Prompt repetition gave larger improvements, specifically on the multiple choice tasks when the options were placed first.
Okay, so that suggests the repetition isn't just a generic boost, it's acting as a stabilizer. It's fixing a specific weakness caused by let's say, a suboptimal input structure.
Precisely. The model seems to struggle to attend to those options when they appear too early, and the repetition fixes that attention deficit. It lets the model process the options after it's already seen the question in the first pass.
Now, this is where the rubber meets the road. To really stress test this, they went beyond those general benchmarks and made their own custom tasks, right?
They did. And these tasks were designed to really test high-precision retrieval, the kind of thing that often breaks LLMs in the real world, like in legal document analysis.
So what were they?
The first was called Name Index. The task was to find the ith name on a list of 50 names, so it demands perfect positional attention.
Tricky.
Very. The second was Middle Match. Find the name or number located exactly between 2 others on a list of 40.
These are great tests. There's 0 creativity, pure data retrieval. It's like asking an LLM, find the 6th clause in this contract, which is a really common enterprise use case.
Exactly, and this is where the proof just becomes undeniable. The gains on these tasks were, well, they were staggering.
Give me the killer statistic.
Okay, so take one of the smaller, more efficient models, Gemini 2.0 Flashlight. On that tough name index task, its baseline accuracy was a pretty dismal 21.33%.
Not great. Basically unusable.
Right, but with prompt repetition, that accuracy soared to 97.33%.
Wow, okay, that's not just an improvement. That's the difference between a system that is fundamentally broken and one you can actually deploy with confidence.
It's a total transformation, all from a simple copy-paste. It completely changes the cost-benefit analysis for using LLMs in these kinds of specific cases.
So we know what works and where it works. But now we have to get to the core of it, the why. From an architectural standpoint, why does simply repeating a query fix these deep-seated attention and ordering problems?
To get that, we have to remember how these models are built. At their core, they are causal language models. And that word causal is everything.
Meaning what, exactly?
It means that when the model is processing any given token, any piece of information, it can only pay attention to the tokens that came before it. It can't look forward in the sequence.
Right. It's like reading an instruction manual one page at a time. If the answer to a question on page 1 is on page 50, you're out of luck when you first read that question.
That's a perfect analogy. If your prompt is question context options, when the model processes that initial question, it has no idea what the context or options are yet. It's already done its processing for the question before it gets the full picture.
But by repeating it,
By sending query, you get around that limitation. When the model starts processing the second instance of the query, it now has the entire first instance, including all the context and options available in its history.
so the second question token can now attend to everything that came before it, including the options and the first question. It gets a fully informed second pass.
You got it. It resolves that causal limitation by making sure all the relevant information is always in the past when the critical attention happens.
Which brings us to the elephant in the room. Efficiency. We're
Right.
doubling the input tokens. Doesn't that mean we're doubling the cost and maybe the time?
A crucial question, and this is where the story gets even better for deployment. The cost does increase, yes. You pay for more input tokens. But the time cost, the latency, stays surprisingly low because all that extra work gets moved to a highly efficient part of the process called the pre-fill stage.
Okay, define that for us. What's the pre-fill stage?
So think of an LLM request in two phases. First is pre-fill, where the model processes your entire input prompt all at once in parallel. It's getting everything ready. The second phase is generation, where it produces the output one token at a time, sequentially. And that sequential part is where latency usually comes from.
So because the repeated prompt is all input, it gets handled in that super fast parallel pre-fill stage.
Exactly. The added compute time is minimal, especially when you compare it to adding tokens to the output, like with chain of thought, which happens sequentially and slows everything down.
So that gives us some huge practical benefits.
Three big ones. First, it doesn't make your final output any longer, so that sequential decoding time stays low. Second, it generally doesn't increase your overall latency. The researchers found it held firm across most tests.
Was there any exception?
It's just one, a minor one. They only saw latency increase when they were using the Anthropic models on extremely long, 3 times repeated prompts. So really at the extreme edge.
And the third benefit?
Simplicity. It's a drop-in change. You don't have to re-engineer your output parser or anything. It just works.
And to make sure this wasn't just about giving the model more thinking time with a longer input, they ran a control experiment, right? The ablation study.
They did. They used what they call the padding method. So instead of repeating the prompt, they just added a bunch of useless characters, like periods, to match the length.
And the result?
As you'd expect, zero performance gain. It confirms the benefit is entirely semantic. The model needs to see the actual content of the query again to fix its attention, not just a longer string of tokens.
This brings us to the nuance. We've been focused on non-reasoning tasks. What happens when you throw prompt repetition into a scenario that already has reasoning, like a think step-by-step prompt?
Now that is fascinating. When you enable chain of thought, prompt repetition becomes, well, mostly neutral, maybe slightly positive. The numbers were 5 wins, 1 loss, and 22 ties.
So no big gains, but it doesn't hurt anything either.
Right. And the reason for that is pretty intuitive, actually.
The models are already kind of doing it themselves.
Exactly. Models that are fine-tuned for reasoning have often learned this trick. When you tell them to think step by step, what's the first thing they often do? They restate or summarize the user's request before they start solving it.
So they have a little internal prompt repetition built into their process already.
Pretty much. So adding the external repetition on top doesn't provide that same dramatic leap because they were already doing their homework, so to speak.
That's a key distinction for anyone listening. If your task is complex logic, stick with chain of thought. If it's fast, accurate retrieval, use prompt repetition.
Absolutely. It's about choosing the right tool for the job. CAUSal is great for logic, but it kills your latency. Prompt repetition is for getting fast, accurate answers from the data you provide.
Did the researchers explore pushing this further? What about repeating it 3 times?
They did. They tested prompt repetition times 3, and they found that sometimes, particularly on those really hard custom tasks like name index, tripling it did substantially outperform just doubling it.
So there's a point of diminishing returns, but for really dense, tricky context, maybe more is more.
It suggests that, yeah, for most general tasks, doubling is probably the sweet spot. But for those extreme edge cases, it might be worth trying a third repetition.
So looking forward, the authors have basically identified this as a sort of an architectural band-aid for how causal models work. Where do they suggest this research goes next?
They lay out a few interesting paths. First, they suggest exploring repeating only parts of the prompt. For really long queries, maybe you only need to repeat the crucial question part, not the whole thing. That could save on token costs.
That makes sense.
Second, and this is more fundamental, they want to look at improving efficiency even more by optimizing the model's KV cache.
The key value cache.
Right, which stores the computed states of the tokens. If you could find a way to only store the second, more context-aware repetition in that cache, you could potentially neutralize the overhead from the doubled input completely.
So that's taking a simple observation, just copy-paste the prompt, and turning it into a roadmap for making LLMs fundamentally faster and cheaper. So what does this all mean for you listening right now? The core takeaway seems crystal clear. If you are relying on an LLM for factual QA, data extraction, or any task that needs quick, accurate retrieval without complex reasoning, prompt repetition is a low-cost, high-yield strategy you should probably implement today.
I think so.
It's maybe the simplest way to turn unreliable baseline performance into near-perfect accuracy, all by just working around the architectural limits of these causal models.
And that leads to a final provocative thought for you to consider. Given how reliably this trick fixes performance issues caused by simple input ordering, that whole options first problem, it really makes you question the nature of LLM fragility. Well, how much of the unpredictable behavior we see, the stuff we attribute to a model just not knowing an answer, especially in basic retrieval, how much of that is actually just a hidden structural problem, a problem that could be solved if the model just got to read the instructions twice?